Science is simply the word used to describe a method to organize our curiosity. Well, who disagrees? Certainly not me. Good morning, one and all present here. I, Abhyudaya Bhatnagar, along with Shreya Batla, welcome you all to Einstein's backyard, an enthralling journey through the world of science. Throughout this journey, you will face you will face the world of microorganisms. You will see the world of science and beyond. I mean, isn't it interesting? Really interesting, right?
With this as a backdrop of this event, I would like to extend a very warm welcome to our Honorable Principal Ma'am, respected Vice Principal Ma'am, and science enthusiast Headmistress Ma'am. I'd also like to welcome a special guest for the day, Dr. Vaishali Garai, who obtained her PhD from the Indian Institute of Science, Bangalore. She is a both NET and GATE qualified in physics and currently working at the Dayananda Sagar University as Assistant Professor of Physics. She ranks among the best teachers of physics at the DSU. She is an early career research awardee from the Department of Science Technology for her research in sensor design. She participates in teaching physics to school kids through fun activities, and she believes there's no better way to learn the subject than through exploration. We are lucky to have you here with us, ma'am.
Thank you so much.
What a privilege indeed it is here to have you, ma'am. And I know you're all wondering when I'll stop talking and let your amazing specimens steal the show. Well, I'll let the golden moment come as we have our first experiment. Haldimetry to Save Our Skin by Muskan Pathak.
Good morning, ma'am. I would like to welcome you with my chemicals. Welcome, respected ma'am, to our DPSW Science Fair Festival. Today, I, Muskan Pathak, will be demonstrating Haldimetry to save our skin. In this experiment, I will be testing the pH of different brands of soap to find out whether they are safe to use in our skin or not. We come to the first question. Why have I used the term Haldimetry? Today I have used the term Haldimetry because the pH indicator that I'm using today is turmeric, aka Haldi, which is a natural pH indicator that I will be using to test these soaps, to test their basic and acidic nature. So now we understand why have I used Haldi as a pH indicator for today's experiment. 1. I want my experiment to connect to the common man. The common man may not have access to synthetic indicators such as phenolphthalein and methyl orange at home. So today I have made it a point to use Haldi as a natural indicator which everyone can easily find at their home since it has many uses such as cooking, cleaning, medicinal properties, so it is available at everyone's home. Second, our ancestors have been using Haldi since ages to come as due to its antibacterial and antiseptic properties, thus it is only right if I use it for my experiment as well. The pH scale. Before I begin my experiment, I would like to explain the pH scale. The pH scale is a range of numbers from 0 to 14, which are used to determine the acidic and basic nature of a substance. A pH of around 7 indicates that the substance is neutral in nature, and a pH below 7 indicates that the substance is acidic in nature. A pH above 7 indicates that the substance is basic in nature. Now the soap base. Since I'm doing my experiment on soap, I would like to explain the composition of soap. Soap bases are basic in nature. They are made of glycerine, distilled water, surface active reactants, and fragrances and essential oils. Since we know that soap bases are basic in nature, we must also know that the pH of our skin is not basic. The pH of our skin is around 5 to 5.5. So thus using soaps which have a high basic nature will affect our skin and make it dry, rough, itchy. Since our skin is also a living organism, it needs a proper pH value to function. Before I begin my experiment, I would like to demonstrate what happens when Haldi is added to an acid and a base. Here in this container, I have NaOH, which is basic in nature, and in this container, I have acetic acid, which is acidic in nature. So upon adding haldi, let us see what happens. Haldi in its natural form is yellow in color, but adding it to any wedge which is a base, we notice that it turns red. Thus, we conclude that when haldi is added to a base, it turns red in color. Now, what happens if we add haldi to an acid? We can see that this acid is transparent and the haldi we have is yellow. So now adding the haldi to the acid, we see that there is no change in color. Thus, from this we conclude that haldi turns red in a base and remains the same in an acid. Moving on to the site of experiment. Here I have a few different brands of soap. One, I have Dettol hand wash, I have Dove soap, I have Lux soap, and I have Vim Bar. So I have chosen these soaps today to demonstrate their acidic and basic nature. So the first soap that I will be testing is Vim Bar. I have grated the soap and I have made a solution of it, an aqueous solution in water. So the first soap that I will be testing today is Vim Bar. As we all know, Vim Bar is not meant to use in our skin. It is used to clean utensils. So according to our hypothesis, it must have a high pH value. It must be basic in nature. It must be highly basic in nature because it is not meant to be used in our skin. So it doesn't have to be customized that way. The second I have used is Lux soap. Lux soap is a bathing soap. So we can say that it must not have a high basic nature since it is meant to be used in our skin and it should be soft on our skin. The next that I have is Dove soap. Dove soap is also a bathing soap. Thus, the same as Lux, according to our hypothesis, it must have a lesser pH value so that it suits our skin. And the next, I have Dettol hand wash, and the same as Dove and Lux soap. It is meant to be used in our skin, so it must not have a very high basic nature. Now, demonstrating with haldi, let us see what happens when we use this natural pH indicator to test these substances. Now, adding haldi to the Vim Bar, we see that it turns a very dark red. So, this indicates that Vim Bar is highly basic in nature, thus it has a very high pH value and it is not meant to be used in our skin, so this is excusable. Next, we move on to Lux soap. Now, upon adding to Lux soap, we must not notice a very red color because it is a bathing soap, and it must not turn red since we noticed that in basic substances, haldi turns red, while in acidic substances and neutral substances, it does not. When we add haldi to Lux soap and stir, we notice that it slowly turns red. Thus, we can see that Lux itself has a high basic nature and high pH value, even though it is a bathing soap. Now let us test out the remaining substances. If we add haldi to Dove soap, we see that the color remains the same. It remains yellow as it was. Thus, we can say that Dove soap has a lesser pH value and it is safe to use in our skin. If we test the last substance that we have, that is a Dettol hand wash, we see that the haldi does not change color even in the Dettol hand wash. Thus, we make sure that even the pH value of Dettol hand wash here is very less. Now, comparing with the color of all of these substances, we see that Vim Bar has the darkest red in color. And Lux soap is comparatively lighter, but it is still red in color. Then the next substance that we have is Dettol hand wash, which is lighter as compared to Lux and darker as compared to Dove. But we can see that both of these substances are still yellow. So they have acidic properties or neutral properties. From this experiment, we can conclude that Vim Bar is the most basic in nature, followed by Lux, followed by Dettol hand wash, and finally ending with Dove. Thus, we can conclude that among the bathing soaps, Lux is not good for our skin, whereas Dove is safe to use. Now comes a solution to the problem. Now we know that Dove soap is very expensive, so it is not affordable by the common man. Not everyone will be able to afford Dove, even though we know that it's safe to use in our skin and it's better for our skin. So what is the remedy here? There's a very simple answer to this: homemade soaps. We ourselves can make soaps at home using ingredients that are available at home. Since soaps are biodegradable in nature and can be made by ourselves without being chemically processed, so they will also not require a soap base, which is basic in nature. That will also help nourish and keep our skin safe, since we will not require any harmful substances. I would like to end this experiment by saying that uh, these substances, among these substances, wind bar is the most basic and Dove is the least basic in nature. So we can conclude that the safest product to use among all of these is Dove soap. Thank you.
Thank you, Muskan. It's definitely time that I changed my soap to Dove. Next up, we have experiments on plasmolysis by Vriti.
A very good morning, ma'am. And today I would be presenting a small experiment on the plasmolysis of an onion peel. Before I would be doing the experiment, I would like to show you all what exactly is plasmolysis. Plasmolysis refers to the shrinkage of the protoplasm of a plant cell from its cell wall due to the exosmosis under the influence of hypotonic solution. Exosmosis is a type of osmosis where the water content moves from outside the cell, inside the cell to outside the cell. Hypotonic solution is a particular type of solution in which there is a greater concentration of soluble particles outside the cell than inside the cell. Therefore, examples of hypertonic solution are salt solution and sugar solution. Plasmosis can be divided into two types, concave and convex. Convex plasmolysis, it can be reversed by placing the cell in a hypotonic solution and you can get back the cell to its original state. Whereas in convex plasmolysis, excessive loss of water can lead to the collapsing of the cell and subsequently can lead to the cell death also. Next, the various stages which are involved in plasmolysis. The first stage involved in plasmolysis is incipient cell plasmolysis. This is the initial stage where the cell loses water and it begins to shrink in volume. In evident plasmolysis, during this stage, the protoplasm gradually begins to shrink to the bottom of the cell and gradually detaches from the cell wall also. Next, the final plasmolysis. This is the last phase where the cell completely shrinks to the bottom of the plant cell. Next, the uniqueness of plasmolysis. During plasmolysis, since the gap between the cell wall and the cell content increases, this results in the loss of turgidity, due to which the plant cell might fail to stand upright. But this plasmolysis process is very helpful in determining the osmotic pressure of the plant cell and determining the living nature of a cell. It can also be used as a preservative means to preserve pickles, meat, jellies, etc. I would be now moving into the experiment, and I have used glass cup, microscopic slides, microscope, onion peel, NaCl, and distilled water. First, I have placed the onion peel onto the slide and placed it under the microscope under the magnification of 2000x. After 15 minutes, I have put 2 to 3 drops of 11 molar NaCl solution onto the slide and used a filter paper to help the water seep into the onion peel with the help of capillary movement. I have observed that when I just place the onion peel slide under the microscope, these were the results, and this is the protoplasm. After 15 minutes, when I added the NaCl solution, I have noticed that the protoplasm has shrunk to the bottom of the cell, and this will differ from cell to cell. Therefore, we will notice non-uniform plasmolysis, which is taking place in onion peel. Moving on to deplasmolysis of an onion peel, which is the reverse of plasmolysis. The onion peel, as we have seen, undergoes concave plasmolysis. Therefore, it can be reversible into its original state, original form, and turgidity can be also retained. Therefore, by putting in a hypotonic solution, water moves from outside the cell to inside the plasmolysed onion peel cell, and the size of the protoplast gradually increases. The precautions while doing this particular experiment are: avoid using any liquid while preparing the onion peel slide for better results, and avoid using any stains such as methyl blue or saffron for color appearance. Thank you.
And that was indeed pretty informative. Now we have a long and an interesting subject: finding exoplanets by assessing the dynamical packing of Kepler multi-candidate systems by Karthike Pandey.
Hello, am I audible?
Yes, yes, you're audible. Yeah.
So, good morning, ma'am. After so much biology, good morning, ma'am. After so much biology, let's move on to finding planets that we can possibly live on one day. My project is finding exoplanets by assessing dynamic packing of Kepler multi-candidate systems. The question that I've asked here is, can exoplanets initially overlooked by transit surveys be found using existing data? In simpler words, what I mean to say is, can planets which were not detected by the Kepler telescope during its first look be detected using already existing data that we have? Planets that were either too small or had a longer cycle than this detection time, or planets who moved just above or below the rim of their specific star and therefore were not detected by the telescope, which detected planets using dips in light. According to the packed planetary system hypothesis, if Kepler multi-candidate systems are unpacked, they can contain additional exoplanets. Thus, identifying unpacked regions in multi-candidate systems can lead to prediction of unidentified exoplanets. Now, what is the packed planetary system hypothesis? The PPS hypothesis postulates that planetary formation is highly efficient, resulting in planetary systems that are dynamically packed and cannot contain additional planets. This was proposed by Barnes and Raymond in 2004. In simpler words, it means that any planetary system will try to accommodate as many planets as possible while remaining stable in its planetary system. In an example here, we see that there are 3 planets which had been detected in the system. According to the PPS theory, a fourth undiscovered planet can also be seen, which can be calculated using very simple mathematical approach, which can be seen using the lighter shades here. Now, how do we select candidate selection and their masses? How do we select what planets we have to look for? Because there are so many planets and so many systems. How do we know what we look for? The exoplanet candidates were used from the Kepler DR25 catalog, available in the NASA Exoplanet Archive. The Forecaster program was used to predict Kepler candidate masses based on their radii. Forecaster predicts the possible distribution of masses for each candidate radius based on four segment least squares fit of 316 well-constrained celestial objects. The predicted mass and uncertainties are given by the mean and standard error of mass distribution. To validate the planet's masses predicted by Forecaster for this investigation, the Forecaster predicted masses were compared to a subset of confirmed exoplanet systems. Over here, we selected specific pairs of planets that could be checked for having intermediate unpacked planets. Now, how do we know if a region is of stability, and how do we find unpacked pairs? We find unpacked pairs using this formula. if the critical distance, which is the minimum dynamical spacing between planet A and planet B, has to be lesser than two times A2 minus A1, which is planet semi-major axes, divided by A2 plus A1 into the mass of both their planets divided by 3 times the mass of their star to the power 1 by 3. For a host of intermediate planets, we check these delta 1x and delta x2. For given AX for solving AX gives us a minimum AX minimum, gives us a AX minimum and AX maximum. The minimum and maximum semi-major axes an intermediate planet could have while remaining a stable orbit between the two planets. We calculate the AX minimum, AX maximum using the formulas given here. If AX minimum is lesser than AX maximum or equal to, then the pair is unpacked. Sufficient dynamic spacing exists between these planets, between planet A and planet B, for an intermediate planet X to be there. Setting for equations AX minimum and AX max equation and solving MX determines the maximum capacity, the maximum mass of that hypothetical planet that could be there without destabilizing this newly unpacked pair. The solution of the system AX min is equal to AX max also provides the ideal semi-major axis where the maximum mass be held in a stable orbit. Now calculate the mass efficiency of that planet. To determine the mass capacity of a planet pair is indicative of undefined intermediate planet mass, the mass efficiency was calculated. A packed system with an unidentified intermediate planet was simulated by removing an intermediate planet in a packed triplet. The mass efficiency was calculated by finding the ratio between the removed planet as published in the NASA Exoplanet Archive and the mass capacity of the planet formed by the remaining planets. To determine the ideal semi-major axis is indicative of the unidentified planet's actual semi-major axis. The semi-major axis deviation was calculated. The semi-major axis deviation, or ADEV, is the deviation between intermediate planet's semi-major axis, as published in the NASA Exoplanet Archive, and their ideal semi-major axis is A ideal minus A by A. The cumulative distribution of semi-major axes for semi-major axis deviation for each delta critical. When delta critical is equal to 10, 95% of intermediate planets were located at the semi-major axis within 9.9% of error of the ideal semi-major axis. When delta critical is 12.3 and 21.7, 95% of intermediate planets had an ADEV of less than 12.4% and 24.28% respectively. What conclusions do we reach on? The conclusions we reach on are the number of potential planets. Dynamical structures of all Kepler multi-candidate systems were assessed. Many systems were found to have unpacked planet pairs capable of hosting intermediate planets. Possible masses in semi-major axes then were constrained for these unidentified planets. Overall, Kepler multi-candidate systems have an error, may have 701 if delta critical is equal to 10, 559 if delta critical is equal to 12.3, and 206 delta critical is 21.7 additional planets. 27.1, 28.21, or 16.99% of these planets respectively could be Earths or sub-Earths. Super-Earths are predicted to have the most common among these potential planets. Predicting semi-major axes, the cumulative semi-major axis deviation for packed planet triplets suggests that the planets tend towards orbit with balanced gravitational forces, identifying most probable potential planets. The cumulative semi-major axis deviation results also could help identifying pairs within unpacked planet triplets more likely to contain an unidentified planet. A semi-major axis of a known intermediate planet that deviates from the expected ideal by more than the amount observed for 95% of the planets could signal the presence of an unidentified planet, preventing the known intermediate planet from orbiting in the expected gravitational value. Implications of the PPS. Finding potential planets suggested in the investigation would support the PPS hypothesis by demonstrating extrasolar systems tend towards a dynamical packing architecture. Not finding these planets could suggest the need to modify PPS, look to alternate theories to describe extrasolar system architecture, and develop different theories. Limitations. This investigation is limited by the uncertainties in the Kepler data and the forecasted predicted masses. A Monte Carlo simulation can be used to iterate through the possible ranges of all variables used in the system, to calculate uncertainties for predicted planet parameters and identify the most probable conditions. Additionally, the delta critical metric used to measure stability approximates system stability that does not consider orbital eccentricity or inclination. Alternate approximations of stability, such as those used in Gladman or N-body simulations, could be used to define identified regions of stability within planet pairs and constrain parameters for potential planets. What are the next steps we can take? In the future, the masses and semi-major axes found in the investigation will be used to anticipate potential planet transits and radial velocity signals, thus facilitating more target searches with greater sensitivity to signals from low signal to noise ratio. The unpacked planet triplets most likely to host unidentified planets will be identified by looking for intermediate planets with large semi-major axis deviations. A target list will be created, and transit timing variation, and radial velocity signals will be simulated. At raw transit and radial velocity data will be searched for signal analogous to the simulated signals to identify new exoplanets previously overlooked by surveys. These are the few references and papers I used to obtain this information and research about it. Thank you.
Yeah. Can I ask a few questions?
Yes, ma'am. I was just
Yes,
about to ask you if.
Yeah. Can you just okay? Karthik, right? What's your name?
Yes, ma'am.
Karthik, right? Yeah. Karthik, it's a good presentation. First of all, I will tell that one. Only few queries I have. Can you just show that graph that you showed, the deviation and the cumulative something you were showing that one? So yeah.
Yes, ma'am.
What exactly is this one? Can you just explain a little bit more, because I didn't get a clarity of this graph.
Ma'am, so the graph.
The x-axis is the deviation of the semi-major axis, right?
Yes, ma'am.
And what is this percent of planets? What exactly?
Ma'am, percent of planets over here means what kind of planets can be there, what percent of planets could be in those specifically, with those specific data criticals, with those deviations at the same time. So a deviation of up to 20% of delta critical 10, the number of planets could range somewhere close to above 100%. So most planets of a delta critical 10 will have an axis deviation of 20%.
Yeah, this delta critical, you found it out by something like delta x1 and delta x2, right?
Yes, ma'am.
Yeah, what is that one, delta x1 and delta x2? Can you just explain that one?
Yes, ma'am. Ma'am,
Yeah.
so for a pair of intermediate planets, we have to calculate the to know the delta critical, we have to calculate the delta between one planet and the intermediate postulate planet and this intermediate planet X and the other planet. So because it was a set of 3. So we use this to calculate delta X1 and delta 1X and delta X2.
Delta x1 it should be, right? Or x1
Ma'am,
and
1X.
delta 1X.
Because we've calculated something in the middle. So we have to take it
Okay.
in a single order.
Understood. Yeah, then.
Ma'am, so we then have to calculate these for
finding out this one, right?
Finding that delta critical more accurately and AX and AX min and AX max.
Okay, fine. Thank you, Karthik. Thank you so much. Yeah.
Thank you, Karthik,
like
for
to have
this.
Lovely ma'am's opinion. Ma'am, please.
Frankly speaking, I have to be honest that this was a little high flown for me to understand. But I am very happy that we have come to this. Like we're able to showcase our students' work like this. And earlier it wouldn't have been possible. And this was something that I've always told Sumana, that I want children to indulge in this kind of research and come up with these kind of ideas and theories. It will be so nice, and I'm really happy about that. I'm looking forward to some more presentations which would be at my level of understanding.
Yes, ma'am. More are coming.
Thank you, Karthike, for this very intriguing knowledge that you have imparted us with. Next up, we have Andromeda by Akriti Mishra, Shruti Satish, and Anusha Tatiraju.
Good morning, everyone. We are Group Andromeda, and today we are going to show you how we scientifically recolor raw data. The colors we see in the world around us are the result of the way that the human eye and the brain perceive different wavelengths of light in the visible part of the electromagnetic spectrum. X-rays and other wavelengths cannot be seen with the human eye. To see the invisible wavelengths, detectors sensitive to those of other wavelengths are required. We need to present these images in a form visible to the human eye. And that is why we undertook this project with the help of raw X-ray data from NASA's Chandra Observatory to depict celestial bodies in its most scientific yet artistic form.
Images taken by telescopes that observe at the invisible wavelengths are sometimes called false color images or representative color images. A false color image is an image that depicts a subject in colors that differ from those that a normal photograph would show. The term false color is typically used to describe images whose colors represent intensities outside the visible portion of the electromagnetic spectrum. Variations in intensities in an X-ray image are usually associated with the variations in the density or concentration of hot gases evolved due to nuclear reactions.
I think she's muted, right?
Really? Akriti, right?
Akriti, you're on mute.
Yeah, Akriti is muted, yeah.
Am I audible now?
Yeah.
Yes, Akriti, you're audible. Yeah.
We are provided with raw grayscale image data that is then transported into an image analysis software where adjustments are made to emphasize the individual features. The colors we choose, red, green, and blue, are mapped according to the wavelength, such that the longest wavelengths emitted are mapped to red, the shorter ones are mapped to green, and the shortest is mapped to the blue color.
So you're saying that we are editing the X-ray images?
In a way, yes, but coloring an astronomical image involves the careful selection of colors chosen to represent some characteristics in an image, such as intensity, energy, and chemical composition. Note that at no point in this process are the images being modified to create that something that isn't there in the data set. We're just making it more perceivable to the human eyes.
Now let's have a look at our final images. Kepler supernova is a supernova caused by the transfer of material between two smaller dwarf stars. Cassiopeia A is a supernova remnant in the constellation Cassiopeia. The different colors are due to iron, which is red, oxygen, blue, and magnesium, which is green. Tycho supernova remnant. This type of supernova occurs when a white dwarf star pulls material from or merges with a nearby companion star until a violent explosion is triggered.
N132D is the brightest in the Magellanic Clouds and belongs to a rare class of oxygen-rich remnants. Most of the oxygen that we breathe on Earth is thought to have come from explosions similar to this one. Centaurus A is the closest active galactic nucleus. In the heart of Centaurus A lies a supermassive black hole, the mass of 55 million solar masses. SN1006 is similar to the Tycho supernova remnant. This type of supernova occurs when a white dwarf star merges with a nearby star such that a massive explosion is triggered. Akriti, you're again on mute.
G2 times 2.0 plus 1.8. Supernova remnants like this, SN1006, and Tycho's supernova remnant are the debris from exploded stars. It is a rare type of supernova remnant containing large amounts of oxygen. 3C58. This pulsar is notable for its very high rate of cooling, which is unexplained by standard theories of neutron star formation. The orientation of the equatorial belt suggests that the parent star maintained the same spin axis before and after it exploded. ETA Carina. ETA Carina is a double star system, two stars orbiting around the common center, which contains one of the biggest, brightest stars of our galaxy. It is expected to have at least one supernova explosion in the future. Let's have a look at how the process was carried out.
We have a video which we have taken. It's basically a screen recording of the process which we took to recolor the images. So it might take some time to load. So thank you for your time and patience.
Ma'am, I'm actually playing the video. I think it's not visible then.
Yeah, it's not visible.
The video is playing in the background. So
You can
have
do
only
one thing, Kriti. You can just share that screen where the video is getting played. So you're sharing
yes, ma'am,
this
I'll
screen,
reshare
right?
it.
Yeah, yeah. That is the reason it is not. Yes.
With this, we would like to conclude our project. We hope you enjoyed it and thank you for your time.
So what is this? Yeah, thank you. Yeah, it's a very beautiful presentation and a nice video. I would like to know what is the software that you have used for this one, for making this, giving color to the images? Is it?
We used GIMP and GMIC. Like for some filters, we used GMIC and major was GIMP.
Okay. And you have given these colors based on the radiations that are emitted by the different bodies, right?
Yes.
Correct.
Yes,
So you have taken the entire electromagnetic spectrum, starting from one end to the other end fully.
ma'am,
Fully
the
have you
images
taken
we
or have you
choose,
taken? Tell.
The images we chose, they had three images. So we decided to choose like three colors, red, green, and blue, based on the spectrum. So red was for the longer wavelengths, the images which had come from the longer wavelengths, and the shorter wavelengths were colored blue.
Okay. So have you calibrated it with the proper wavelengths that come out, and you have done that one?
Yeah.
All right. Good. Nice. Thank you.
Thank you so much.
Thank you, ma'am.
Well, that was really beautiful and interesting. Up next, we have Martian Comms Link by Arnav Kulusheswara.
Good morning, everyone. Good morning, everyone. Welcome to Project Martian. My name is one second. Good morning, everyone. Welcome to Project Martian. My name is Arnav, and I'll be taking you through Project Martian. In this project, we will be launching a rocket from Earth, and using the rocket, we'll be landing a rover on Mars, and also we'll be deploying a satellite in the orbit of Mars. So let me guide you through the launch now. So let's begin with the launch. As you can see, the rocket has been launched. About the height of 10 kilometers, we'll have to take our angle of attack to an angle of 45 degrees. Our apoapsis will be somewhere near 100,000 meters. And as you can see, our booster stage has been separated. Now we'll be cruising through a height of approximately 40 kilometers before we turn our angle of attack to 90 degrees. Now we'll be turning our angle of attack to 90 degrees. We have almost escaped Earth's atmosphere and entering space. Our second stage has been deployed, and now we are cruising on an vacuum booster. So now we have set our apoapsis at 100,000 meters, and we have gained enough vertical speed to do our orbital insertion burn. After this orbital insertion burn is complete, we will be successfully in lower Earth orbit. Now we'll plant a trajectory for Mars. As you can see, our solar panels have also deployed. After plotting a trajectory for Mars, we'll burn our fuel until we escape Earth's sphere of influence, and then we'll plant a trajectory to our Mars sphere of influence. After that, we'll cruise in space for approximately 7 months before entering Mars's sphere of influence. Now we'll be cruising in space for 7 months. After 7 months, you can see we are passing by Mars now. If we don't decrease our speed, we'll exit Mars's sphere of influence as our trajectory goes towards the sun. Now over here, we'll be decreasing our speed by doing a retrograde burn. After this retrograde burn is complete, we'll be successfully in Mars's orbit. Once that is done, we will be deploying a communication satellite, which will relay our signal from the rover to Earth. Over here, our satellite has been deployed. Now we'll extend the solar panels, the radar, and this satellite will also help us to locate for further potential landing spots. Now, after that is done, we'll be decreasing our velocity even further to intercept with Mars's surface, where we'll be deploying our rover. Our path for landing is simple. First, we'll be decreasing our speed using aerodynamic resistance. Once that is done, we will deploy some parachutes and slow our speed even further. After that, we'll cut our parachutes and land on boosters. Now we have entered Mars's atmosphere. Soon our parachutes will be deployed. Once that is done, we'll be cruising to a height of at approximately 200 meters on parachutes. Once we are at a height of 200 meters, we'll cut our parachutes and land using boosters. This rover has deployable solar panels and antennas for communication with Earth and photovoltaic power. It also has surface scanning units, gravitational scanning units, atmospheric scanning units, and seismic accelerometers. All the information and science it has collected from the surface of Mars will be sent to the satellite, which will be relayed to the surface of Earth. Thank you.
What's your name? I forgot.
Ma'am, my name is Arnav.
Arnav. Arnav. Beautiful. What is the platform you have used for making this one?
Ma'am, I've used a space flight simulator. I've used a simulator, but I have designed the rocket, rover, and every satellite myself.
Okay. Okay. Very good. Good. One thing is you told about this retrograde burn, right?
Yes,
So
ma'am.
can you just a little bit detail about this one when we
Ma'am,
are
so
trying
once
to?
you once you're in
Yes.
space, you have to go according to your orbit, because
Correct.
once you are in space, everything is circular because you're in an orbit. So you can't just define directions like north, south, east, and west. There are in space everything is three-dimensional, right? So over there you have retrograde, prograde, normal, anti-normal, and radial in and radial out burn. All of these are relative to the planet. So okay, for example, if you're going in an orbit, if you have to increase your speed, you have to do a prograde burn. In the prograde burn, you'll be burning to increase your speed and the height of your orbit. And the retrograde burn is exactly opposite to the prograde burn. You'll be decreasing your speed and your orbit. In the anti-normal burn, you'll be changing the inclination of your orbit towards negative side. And in the normal burn, you'll be changing the inclination of your orbit towards the positive side. And in radial in and radial out burn, you'll be burning inside, facing inside the towards the earth and opposite to the earth.
Okay. All right. Another one small question. Do you know how the solar, we all know, right? The solar panels are there and they are very much used in. So what is there inside the solar panel? Any
Ma'am,
idea?
yes, ma'am, I have an
Yes.
idea.
Yes,
So, ma'am,
please
these
share.
solar panels are actually made up of semiconducting surfaces such
Okay.
as zinc, and these are based on Einstein's photoelectric effect. As Einstein in his photoelectric effect told that light is a particle than a wave. Um, yeah, that's all I know.
Basically, the solar panels, they are made up of PN junction. Okay, these P-type and N-type semiconductors. So since solar cells are made up of PN junction, and the generation happens when radiation falls and you get electron and hole pairs generated. Okay,
Yes, ma'am.
all right, good, nice presentation.
Thank
All
you, ma'am.
right, thank you, thank you.
Wow, wasn't that out of this world? Now let's get back to Earth and check out C.I. Morgan's physics engine.
Is it visible?
Yes, yes, it is very much.
Good morning. My name is Sia, and I will be talking about how I believe that the universe might be a conscious being. We've launched several telescopes into space, like Hubble, and we've also covered a vast portion of space. And we have so many ideas of life beyond Earth, beyond humans as a species. However, we haven't succeeded at this yet. Keeping in this in mind, I wondered, how is Earth the only planet in the vast universe where life can exist? I began to question what reality exactly is. What or who decided how subatomic particles should come together? What if Earth has life simply because it is more evolved than other planets where life may appear? As we go throughout history, we realize that there are various theories that have come up, and all these are basically stories that we make to inculcate all our past learnings along with new experimentation. For example, we started with the point theory, where we gave each object a specific coordinate in space and studied their properties on the basis of that. For example, we gave each electron a specific coordinate which had its own mass and charge which was constant. With this, we learned the idea of quantum numbers. As we moved on, we realized that distances in space are curved, which broke down the idea of everything being a single point. So the next thing we decided was that it's a collection of points or string theory. And today we follow even more theories. So do we have a theory that explains everything till now? Not exactly. While researching about reality, I came up with 4 points: information, looping, non-determinism, and consciousness. Is the universe information? The reality we see around us is made of information, which is equivalent to symbolism. There isn't really any evidence that says that the reality is not made of information. So information can be defined as the meaning of various symbols relative to each other. So the meaning is subjective, which means that information is subjective and requires choice. How is this choice made? Causality loop. This was a very interesting topic. It basically says that all time exists all the time, it interacts with itself. We assume that our past affects the future because that is how we perceive reality. But why? Why can't the future affect the past? Can it be an endless loop? Well, it's not an endless loop, but then it is a theoretical proposition called causality loops, which says that a sequence of events that happen in the past can affect the future. Similarly, a sequence of events in the future can interact with the past. Non-determinism. Determinism means that there is no free will. Everything happens by an external force or being or object, and everything is written down in hard stone. But the idea of time interacting with itself ruled out determinism. Another excellent example which rules out determinism was the electron double slit experiment. When we pass an electron to one slit, the first one here, we saw a particle nature. Similar to when we throw tennis balls through a single slit, it comes as a band. However, when we pass the electrons to two slits, we would have assumed two bands to pop up, just like they would if we threw tennis balls through them. However, we observed a wave nature. We came up with various theories to explain this nature. Perhaps the electrons were interacting with themselves. So we launched the electrons one at a time, but we still got a wave nature. Then we thought maybe our electrons split just before the slit and come together, interfering with itself. So we decided to place an observer, a detector. However, as soon as we placed the detector, we noticed the electrons moving in a particle-like nature again. It's as if they knew we were spying on them. So what, why, or who decides these movements? Now the real question is the choice of an electron. Why does an electron try to achieve the lowest energy? How does it know where the lowest energy is found? When the universe cooled down, how did it settle the way it did? How did the protons and electrons and other subatomic particles know where to go? So there must be some consciousness within the universe aligning everything just right. Consciousness. What is consciousness? Truthfully, we don't really know. We can call it the state of being awareness. In fact, consciousness is one of the least known things in science. Even in the International Space Station, there is never silence. Astronauts recount tiny, small sounds of meteorites bouncing off the surface. It's as if the universe was alive. Some scientists say that quantum is obscure, and it will remain so unless there is an observing entity. For this observing entity to be present, it must make observations, which requires consciousness. Many scientists do believe that consciousness should be discovered and applied to our physical world, and I completely agree with this. The presence of being a conscious universe can be seen scientifically. It can simply refer to the state of being awake. We are a part of this universe and we have consciousness. It is possible other entities have consciousness. For example, all subatomic particles rearrange themselves to form atoms, molecules, further single-celled organisms, and these single-celled organisms arrange themselves to form a complex organism like us ourselves. In fact, even our brain was essentially made of subatomic particles. As of now, physics has not given us a limit for how many conscious entities can be formed. And we do know that all forces can transfer into each other. So is it possible that they all come together to form a conscious entity? Some conclusions that I made are that everything has consciousness, even the rocks found in nature. However, this consciousness may need energy to be stimulated. For example, when some rocks like shale are put under extreme pressure and heat, they change chemically to form slate. This is done by a rearrangement of electrons within the rocks. And this change is determined by these electrons or subatomic particles. All these particles are trying to come together to form a conscious system in the presence of energy. When the universe cooled down, the subatomic particles came together to form a structure that enabled consciousness. In other regions of space, there may be consciousness that has not evolved into life yet. And with this idea of consciousness, I leave you to come up with your own conclusions and hypotheses. The universe is vast, and there is so much occurring in every fraction of a second. Galaxies interact, stars die, and new ones are born. Asteroids collide, and planets are formed. Every theory tries to inculcate our past learning with new ones. And maybe someday we will achieve a theory of everything, something that explains everything about everything. Thank you.
What's your name? I missed it. Sia, right? Yes. Sia, thank you for your presentation. Just one thing I would like to ask you. This, when you're talking about these subatomic particles, can you tell which mechanics should we?
As of now, we are using quantum mechanics, which use dual nature of particles. And most of it, what I did was based on my understanding from Heisenberg's uncertainty principle.
What is that one? Can you tell what is Heisenberg?
It basically says that it's the whole quantum mechanics is now based on probability because of this principle, which says that it's not possible for us to know the exact position of a subatomic particle, because to see anything we need to give it light, and light gives it energy, which excites the electron in the sense that we cannot see it at once using in constructive and destructive waves.
Not really. It has, we cannot specify the exact position. This one, there is a probability of occurrence of a subatomic particle in a small range. So that is the uncertainty principle of Heisenberg. Okay, so it is. You cannot exactly, like classical mechanics, where we can tell exactly at this point of time, at x equal to say 1 centimeter, we have the particle. That accuracy we cannot tell in quantum mechanics. It's a probabilistic approach. We can tell this is the probability with which a particle can stay at a point, say x equal to 1 centimeter. Okay?
Yes.
Yes. Thank you. Thank you so much, Sia.
Thanks for the presentation. That definitely got me interested. Up next, we have something really enlightening. Presented by Shreya Datta, we have dual nature of light.
Hello, I am Shreyas Datta, and today I'll be taking you through the photoelectric effect of light. I want to be showing the double slit experiment. So now I am going to start with a table of contents. First, I'll give you the basic information about light. Then I'll be talking in slight detail about the photoelectric effect, and then the main part of my presentation, the double slit experiment. Then how I recreated it at home. So starting off, what is light? Is it a particle? Is it a wave? It is both. Light is both particle and wave. This can be proved by two different experiments, the photoelectric effect and the double slit experiment. Photoelectric effect proves the particle nature, while double slit experiment proves the wave nature of light. Then photoelectric effect. This effect, shown by Einstein, proves that photons exist as discrete particles. He did this as such: when you put photons on a metal, it excites the electrons and let them escape. This shows that photons carry a constant amount of charge and cannot be fractions of that. Now, I'll be showing you the double slit experiment. So when you take light is as a wave, as a particle, we expect there to be two parallel lines when you throw them through slits. We can understand this like if we throw to a ball, we always know its perfect trajectory throughout the motion. But in reality, it doesn't work that way. We get an interference pattern. So the interference pattern happens because of the wave nature of light. When we pass light to two different slits, it splits as two different new waves. Now the waves have the property of interacting with itself, creating the interference pattern. Area which are brighter shows the addition of both waves, and the dark spots shows the cancelling of the waves. Then at home, to create the experiment, I use a monochromatic green laser pointer, a double slit, and the stand. So for setting things up, so first I connect my double slit to the laser pointer as such. I mount it to a stand and point it at a screen. So observation, we can see the interference pattern which picture I have taken on my own on the screen. We can clearly see the difference between the normal pointer dot and the pointer with the slit. We can see the interference pattern, which is similar to that of waves, which is clear the constructive interference and the destructive interference. So we can conclude that the pattern shows the wave nature of light. So I finally want to thank you for spending your time on my presentation.
Very nice, Shreyash. I would like to know what is the this one dimension of your slit? Any idea?
Ma'am, it's around 0.5 millimeters each.
0.5 millimeters each. Okay. And can you tell me what is the condition that needs to be satisfied to have a constructive interference?
For constructive interference, the troughs of both waves should be at the same place, which makes the wave add on top of each other, and it creates the brightness. And then for destructive interference is the opposite.
So when you tell two waves are added, what exactly is added? Because wave has frequency, amplitude, wavelength.
It is the amplitude.
Amplitude variation. Okay. All right. Thank you so much, Shreyash.
Thank you, ma'am.
Thank you, Shreyas. Next, we have Surface Tension by Aryan Saha.
I can't hear. Sorry.
Is it audible now?
Yes, I could hear that one, but in the video, the sound is not coming, right?
Hello, my name is Aryan Saha and I am a student of class 11B in the Delhi Public School, Whitefield. Today, for my Science Week project,
Ma'am, it is audible now, right?
Yes, it
Okay.
is audible. Yeah.
I have decided to choose an experiment that demonstrates an interesting phenomenon. that is surface tension. Now, here, as you can see, I have a paper clip floating on the surface of water. Now, one might wonder, how exactly is this floating on water? We, through our common sense, know that the metal of which the paperclip is made has a density much higher than that of water. As a result, the paperclip should sink. So then how is it floating? Well, I will certainly answer that question. But first, let's see if we can replicate this. So now I take off this paperclip, and as is general for trying to make something float on water, I try to place it on the surface of water. As you can see, the paperclip has sunk. This is what we had expected. Now, I will repeat this experiment, but with a slight twist to it. First, I take this piece of tissue paper and I place it on water. Then, I will place this paper clip on the tissue paper. This is similar to a person floating on a raft on the high seas. Now, let's see what happens when we take off this raft or the tissue paper. So, using a toothpick, I soak the tissue paper so that it sinks, leaving the paper clip on the surface of water. As you can see, the paperclip is now floating on the surface of water, as though the density of the paperclip has suddenly decreased. That is the magic of surface tension.
So, as you have all seen, that was the experiment that I had performed to demonstrate surface tension. Now, I have been talking about surface tension in the video, so let me help you learn more about surface tension. Now, what is surface tension? Surface tension, scientifically defined, is the tendency of a liquid surface at rest to contract so as to occupy the minimum surface area possible. Now, one might wonder that why exactly does this surface tension occur? Well, let me explain. As we all know, in every state of matter, there are molecules. Now, I will be taking the example of water to enable easy explanation. As we know, the water has molecules, and each of the molecules have kinetic energy, as a result of which they are always in a continuous state of motion. Now, this continuous state of motion should mean that the surface of water is actually quite crooked. It should not be flat. But we have to here factor in another force, that is the force of attraction between the molecules, or the intermolecular force of attraction. Now, this force of attraction, when acting on a molecule present within the volume of water, it tends to cause the net force on that molecule to be zero, because the molecule is uniformly attracted by other molecules on all sides. But on the surface, this is slightly different. On the surface, the net attractive force is downwards and sideways. This is because the attractive force due to the molecules of the air on the surface water molecules is quite negligible compared to the intermolecular forces of attraction between water molecules. So what is the consequence of this? The consequence is that this water molecules on the surface tend to be pulled downwards until they are balanced by a resistive force from inside. Now, and further, they are also pulled together laterally, thereby resulting in contraction. This results in the formation of something like a skin on the surface of water, making it almost smooth. So now I have talked about surface tension, and in my video, I even said that it is an everyday phenomenon. So one might wonder, where exactly can I experience surface tension? Well, let me tell you. I will be considering two consequences of surface tension. The first one, of course, is a falling droplet of water, or for that matter, most of the liquids. Now, when a water droplet falls, there we see that it always assumes a spherical shape. Yet, when it starts dripping from the tap, it is not necessary that the initial shape is spherical. So why does this happen? This is because the intermolecular forces of attraction on the molecules on the surface of the droplet tends to be inwards towards the center of the droplet. As a result, the most convenient shape for the droplet to assume is spherical, hence the spherical shape of water droplets. The second consequence is one that we might have encountered. This is in reference to an insect known as the water strider or the pond strider. Now, what exactly happens in the case of this insect is that, unlike other insects, it can float on water and sometimes it even appears to run on water. Why is this? This is because the legs of the insects are spread out, thereby causing equal weight distribution, reducing the weight on the surface of water at a particular point. And further, it has hydrophobic hairs on its legs, which also help it in being supported by the surface tension of water. Thank you.
Thank you so much. It was a nice experiment that you have shown. Sorry, I missed the name. What's your name?
Aryan, ma'am.
Aryan. Sorry. Yeah. Okay. So what is this force which is pulling all the water? Can you name that force?
Ma'am, it's the intermolecular force of attraction between the molecules.
There is another name for that one. You know?
Ma'am.
It's the coercive force.
Okay.
Coercive force. Okay. But good. Nice presentation.
Thank you, ma'am.
Thank you. Thank you. Yeah.
Thank you, Aryan, for that presentation. Now we have last but not the least, Tesla Coil by Nishant S. and Ashrit Y. Kumar.
Good morning to all. Today, Nishant and I will be presenting to you a working model of Tesla coil. The world of wireless technology is here. Innumerable wireless applications like wireless power lighting, wireless smart homes, wireless chargers, and so on are developed due to wireless technology. One such great invention is the Tesla coil. A Tesla coil is a radio frequency oscillator that drives the air-core double-tuned resonant transformers to produce high voltages with low current. The Tesla coil is a machine for generating extreme high voltage. This uses high frequency transformer action together with resonant voltage amplification to generate potential. About 100 years ago, Nikola Tesla invented his Tesla coil. Tesla invented his coil with the intention of transmitting electricity to the air. He conducted much research in the area. He proposed using a few coils spread across the globe to transmit electric energy to the earth. Tesla coil, or a resonant transformer of high frequency and high potential, have been in commercial application. The only variation being the high voltages is used to produce an effect other than a spark. Although not all commercial applications of Tesla coil are still in use, some historical and modern day applications include spark gap radio transmitters, induction coil, induction and dielectric heating, medicinal X-ray devices, quark medicinal devices, ozone generators, particle accelerators, and electrical stage shows and entertainment. Every invention has its advantages and disadvantages. Advantages of Tesla coil include allows uniform distribution of voltage throughout the winding coils, builds up the voltage at a slow pace and hence no damage. It gives great performance. The use of three-phase rectifiers for higher power can offer tremendous load sharing. The disadvantages include the Tesla coil poses several health hazards due to high voltage radio frequency emissions that includes skin burns, damage to the nervous system, and heart. This involves high costs in buying the large DC smoothing capacitors. Construction of the circuit consumes much time as it needs to be perfect to resonate. The principle behind the working of a Tesla coil is Faraday's law of magnetic induction. This law states that the induced electromotive force in any closed circuit is equal to the negative of the time rate of change of magnetic flux enclosed by the circuit. This means that whenever a conductor is placed in a varying magnetic field, an electromotive force is induced. If the conductor circuit is closed, a current is induced, which is called the induced current. A magnetic flux is the number of magnetic field lines passing through a closed surface. Now Nishant will be taking it forward.
Ma'am, can you see the video?
No, no, Nishant, I can't see the video.
Now?
No. You can stop sharing this screen and then share the video screen. Yeah.
Yes, ma'am. Can you see the project?
Yeah, I can. Just 1 minute, I'll pin it.
Good
Just
afternoon, everyone. So this is a live working mini Tesla coil project. We are using here a 9-volt battery to produce the potential difference in this circuit. So here we have this the yellow spiral. This is called the primary coil. This is responsible for the producing the varying magnetic field around the secondary coil. This is the secondary coil, which is made up of copper wire. Here, the induced current is it acts as a conductor where the induced current is produced. So this primary coil has three turns, and secondary coil has more than 250 turns. So due to this, the voltage in the primary coil is less, and the secondary coil will have more voltage. This is the same principle used in transformers. So then we see that the primary coil is connected to the this is connected to the collector terminal of the resistor, and the base terminal of the resistor is connected with the transistor. The base terminal of the transistor is connected with the resistor, and the another ending of the secondary coil. And this and the other end of the primary coil is connected to the battery's positive terminal. So this is the transistor used. This is a 2N 222A transistor, and this is a 22K ohm resistor used in this. Now I'll show you the live demonstration of this project. Live working of the project. Yes. So we can see that the light bulb has grown. So actually, basically, current produced near the conductor travels to the air, and in the bulb, the tube of the bulb contains argon and mercury vapors, which produce ultraviolet rays when they come in contact with electric current. This ultraviolet rays affects the fluorescent filament in the inner layer of the tube, the bulb, which glows, and we see light. So thank you, ma'am.
This concludes our project. Thank you, everyone.
Thank you so much. I just have one small question. What is the function of the transistor that you are using there? You have used the transistor,
the transistor basically converts the DC current into AC current, due to which the coils work, like the transformers work on AC current.
Okay. And okay, fine. That's all.
Yes, ma'am. Thank you, ma'am.
Thank you so much.